Yeah, it is present within a metal. Monora, bolo to metallic bonding er definition ki?
The electrostatic forces of attraction between positive metal ions and negative free delocalized electrons.
Shabash, you get 10 out of 10. Very good. So it's the electrostatic force of attraction. Electrostatic force of attraction between positively charged metal ion and negatively charged delocalized electron.
Sir, sea of electrons बोलना होगा ना?
The metallic structure, the metallic lattice is the regular arrangement of positive ions embedded in a sea of delocalized electrons are electrons that are not associated with any So this is the diagram for metallic bonding. So here we have the metal atoms and inner electrons, and here is in the spaces we have delocalized electrons. So what happens? Tomar dharoje, this is a lithium atom. So lithium has a nucleus at the center and 2 electrons in the first shell and 1 electron in the outer shell. So since it has just 1 electron in the outer shell, this lithium atom is not stable. So in order to have a complete outer shell, what happens is it has a nucleus and it has 2 electrons. And the outermost electron is lost to the surrounding. The outermost electron is lost to the surrounding. So these electrons are here. So what does the delocalized term mean? Delocalized term means that a single electron is not specific to any atom. So the electron in black can be attracted by this atom, by this atom, by this atom, by, if there's an atom here, it can be attracted or by this atom also. So this electron, the orange electron, can be attracted here, 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 or even by this atom. So which basically means that each electron is attracted by all its surrounding metal ions. that is the reason we describe metallic bonding as electrostatic. What does electrostatic mean? Anyone? What does electrostatic mean?
They're held in place.
The forces of attraction between atoms and ions, or ions and ions.
It's basically attraction between charges, opposite charges. So that's why it's electrostatic. So electrostatic, forces of attraction between positively charged metal ion and negatively charged delocalized electron. So since the electrons are attracted all around, therefore, when you apply a force, this atoms would be moving on this direction. And then what is going to happen? The electrons are going to rearrange. The whole structure will rearrange. That's why we call metals, they are malleable and ductile. The reason is, when you apply a force, the layers can slide past each other along with the electrons, and then they rearrange themselves and they can form a new structure. That is why metals are malleable and ductile. So how does a metallic bond arise? So write this down, how a metallic bond arises. In a metal lattice, atoms lose their valence electrons and becomes positively charged. The valence electrons no longer belong to any metal atom and are said to be delocalized. They move freely between the metal ions like a cloud of negative charge. Hence, this lattice structure is described as a lattice of positive ions surrounded by a sea of mobile electrons or delocalized electrons. Please write it.
Sir, van der Waals forces, London forces and dispersion forces কি একই জিনিস?
সব একই. London forces, van der Waals forces, instantaneous dipole, dispersion forces, all of them is the same, synonym of each other, synonym. Next, physical properties. Physical properties of metals. We know metals have high melting and boiling point. Why? Due to strong
electrostatic
forces.
Electrostatic forces or strong metallic bonds. So this is because it takes a lot of energy to break up the lattice with its strong metallic bonds. Number two, strength of metallic bond depends on charge on the ion and number of delocalized electrons per atom. So sodium across the period, this is period 3. Period 3, we have sodium, magnesium, aluminium. So sodium has how many electrons in the outermost shell?
1.
Magnesium?
2.
Aluminium?
3.
So ekhane jodi suppose if this is +1 charge, tar mane each atom is just losing 1 electron. So the electron density would be low. But if you have a charge of +2, tar mane each atom is releasing 2 electrons. So your charge density, electron density is increasing. So when your electron density increases, যখন তোমার বেশি electron থাকবে, তখন what would happen? The attraction between the positively charged metal ion and the sea of delocalized electron would be stronger. তাহলে aluminium +3, so each atom is releasing 3 electrons. So তখন কি হচ্ছে? your electron density increases even more, and attraction is even stronger, right? Attraction is even stronger. So you need more energy to break up the bond. Any question? So strength of metallic bond depends on two things. Kiki.
Charge.
Charge of the ion.
Charge of the on the ion and the number of delocalized electrons per atom. So আমি তোমাদেরকে এখানে লিখেও দিছি why aluminum has the highest melting and boiling point. Okay, so next. So that's the diagram for this one, malleable and ductile. Write it down, and then metals are good conductors of heat and electricity.
Sir, do we have to copy the diagram beneath?
Yeah, that's how you find out how to conclude which type of structure a substance is. So first of all, we need to find out, is the melting point or boiling point high or low? If it's high, then it's a giant structure. If it's low, then it's a simple molecular structure. So giant structure can be of three types. It could be metals, it could be ionic solids, it could be giant covalent compounds. So is it an electrical conductor in molten state? If it's yes, then it could be a metal or an ionic compound. If it's no, then it's a giant covalent structure. Thirdly, does it contain electricity in the solid state? If it's a no, then it's an ionic compound. If it's a yes, then it's a metal. So eitai সবচেয়ে important. Everybody draw this table.